Hi, continuing from the previous video on laws of indices, on example 6 there is a power with a constant inside the brackets and they're both squared. The way to answer this question is to take the constant first, 3 squared, and then the x to the power of 4 to the power of 2. Now on this x to the power of 4, all you have to do is multiply the 4 and the 2 together, making that x to the power of 8. So the answer is 3 squared x to the 8. And we know that 3 squared is 9, so the final answer is 9x to the 8. For division, similar to above, we first have to simplify the numerator, which will become 4 cubed multiplied by x to the power of 3 times 3, all divided by 2x cubed. 4 to the power of 3 is 64, x to the power of 9 divided by 2x cubed. And this simplifies as 32x to the power of 6. Now if you have two values on the numerator, you can split this into two separate fractions, the first one being 20x to the power of 7 divided by 5x squared, and plus 15x cubed divided by 5x squared. Taking the constants at the front, 20 divided by 5 is just 4, x to the power of, now this is a division law, so 7 minus 2, plus the second fraction, 15 divided by 5 is 3, x to the power of 3 minus 2, which is 1. So that becomes 4x to the 5 plus 3x. So moving to the next question, what happens if there are fractions? Well, the laws work for fractions as well, so if you have x to the power of a half multiplied by x to the power of 3 over 2, you just have to add the two fractions together. So that would be a half plus 3 over 2, which ends up being x squared. Now if you have a cubed root on the outside of 125x to the power of 6, the easiest way is to separate this into two separate cubed roots. So the first one being 125 and the second one being x cubed. Now the cubed root of 125 is just 5, and now x would be a third times 6, because the cubed root can be written as 1/3. So that answer would be 5x to the power of 2. Now if you have a negative in front of a power, that has the effect of being 1 divided by the expression, so 1 divided by 25 to the power of 3 over 2. Now with fractions, we know that that would become 1 divided by the square root of 25 cubed, because 3 over 2 can be separated as a half times 3, and a half is a square root, and the 3 is cubed. So that is, moving on, 1 divided by the square root of 25, which is just 5, cubed, and that becomes 1 divided by 125. Example 12 is on the next page. Example 12. Now the easiest way to answer these sorts of questions is to convert the square roots and the cube roots into fractions. So the square root of x is the same as x to the power of a half multiplied by the cubed root, which is x to the power of a third. And now we have the power law, because you have a half and a third that you can add together, making that x to the power of a half plus a third, which is the same as x to the power of 5 over 6. And extending this example to a more complicated case, first convert these into fractions. So this is the same as x to the 1/2 cubed multiplied by x to the 1/3 to the power of 4. And we remember from the previous video that x to the power of 1/2 cubed, if you have brackets around the x, you just multiply the powers together. So in this case, it is x to the power of 1/2 times 3 multiplied by x to the power of 1/3 times 4. So 1/2 times 3 would be 3/2 multiplied by x to the 4/3. Now, when you're multiplying, we add the powers. So if I write up here, that would be x to the power of 3/2 plus 4/3, and the final answer would be x to the power of 17/6. And the final example is a division. So again, if you see square roots and cube roots, do that first, convert that into a fraction before continuing. So in this case, that would be x to the 1/3, so the cubed root becomes 1/3, all squared, divided by x to the power of 1/2. So now that would be 1/3 times 2, so that would be x to the 1/3 times 2 over x to the 1/2, which becomes x to the power of 2/3 over x to the 1/6. Now, this is the division law, so we'll take away the powers. That would be x 2/3 minus 1/6, which becomes x to the power of 1/6. Thank you for listening. The notes are freely available on our website, which is shown on the link below.